got it now. Okay, so you can see them now?
Yes.
Perfect. Okay, well, I'll go ahead without the update. Doesn't make too much difference. And I have 20 minutes to speak, and is that right?
Yeah.
Yeah.
Okay.
Perfect. Well,
when you want.
Yeah, I'll go ahead. Thank you, Yanis, and the organising committee. It's a real pleasure to be involved in this sports analytics workshop. My apologies that I've not been able to attend any of the talks so far. I know I've missed some very interesting looking talks, but I hope to attend as many as I can for the rest of the time. And it's a great shame from my personal perspective that I have to give this talk sat here in the UK rather than with you in Athens, which would be much more pleasurable. But nonetheless, thank you for having me involved. This is work looking at what else do we think about at the moment other than the impact of COVID-19 on sport and on football, in particular if we're football fans. We choose our particular area of life, sport, and think about, well, how has COVID-19 affected it? So this is a little bit of an update on some work that I've done previously, thinking about the impact of COVID-19 on football, and a bit of a twist as well, some very recent work with Kai Fischer and Benedikt Schmal, who work in Dusseldorf. So I'm an economist. I'm aware that I'm in a crowd of not necessarily other economists, so I'll try and give a bit of a kind of an overarching theme of what I'm trying to do with this work, and that is to try and think about how sports occur, how sports outcomes occur more specifically. And so economists often think about something called a contest function to try and map, if you like, the outcomes to some of the economics that go on behind the scenes that lead to the particular outcomes that we observe on the football field or whatever our sporting field of choice is. Excuse me. And so the proposal is that the outcome, the probability of the outcome in a game between Team I and Team J is a function of the relative efforts E, I and J, for teams I and J, or participants I and J, where there's an additional parameter gamma, which dictates how the contest translates effort into likely outcomes. And so we can think of certain kinds of scoring systems that might exacerbate differences between teams, and certain scoring systems or players that might reduce the differences between teams, that compensate perhaps for differences and make it harder for the better player or the better team to make a big difference. But the main thing, really, from my perspective, thinking about this right now, is the cost of effort, really, because if you think about it, teams have to produce certain levels of effort to make contests particularly interesting to watch, and expending effort requires costs. There are some costs involved, so CI and CJ for Team I and Team J, and those costs plausibly are influenced by COVID-19. There's lots and lots of evidence out there published on the impact on outcomes of there being no fans, and how that impedes the home team because there are no fans to cheer on the home team perhaps, or influence the referee, and that affects the costs involved for teams in producing to a particular level of effort such that the competition is particularly interesting. What I'm particularly interested in here, though, is COVID-19 prevalence in a local area. So football teams, sports teams exist within some kind of local area. And here in the UK, here in England in particular, there's a lot of professional football teams that sit within particular local areas, and the government's been releasing for well over a year now, 15 months or so of data, daily data on COVID-19 in all of these small-ish local areas around the country, well over 300 of them, of which football teams lie within those local areas. And when COVID-19 happens and we end up with either people the first instance, people being particularly badly affected themselves, being ill themselves, but also the isolation involved. If you have a COVID-19 case in the household and you have to isolate, well, it imposes costs on doing things. Often the kids have to stay at home, for example, and so you can't necessarily be as productive as work as you might otherwise be. And so it's not implausible to think that football clubs lie within local areas. Local areas have COVID-19. If there are lots of cases, and there were particularly plenty of cases in different parts of the country, Birmingham in particular, in the northwest, here in England, such that the costs were not evenly spread between teams. And so arguably that may make a difference in terms of outcomes. And the second thing that I'm going to have a look at, we'll be looking at actually players themselves contracting COVID-19 and what the impact might have been on their productivity levels. I won't spend too much time on this. This is evidence relating to the impact, as already mentioned, of COVID-19 on sport in terms of these are all a bunch of the many papers out there, some of which one of which I've written on the impact on outcomes of COVID-19, there being no fans in the stadium. There's also an impact on the demand for football, quite a complex effect. This first paper here, we looked at the big 5 leagues and found that fans were coming in small numbers in the first few weeks of the pandemic as the numbers began to get bigger. But I also looked at Belarus with Dominic Schreier and Carl Singleton, and there was a big decrease at first, but then a returning of crowds when Belarus didn't stop playing. And then I've got a couple of the references here because thinking a bit more about that spread of COVID-19 in local areas, but also potentially amongst footballers. For example, this is a paper by Schumacher et al. In this year, looking at to what extent do footballers actually spread COVID whilst they're playing the game. And the answer is not as much as you might think, because, well, footballers are playing outdoor and they're not in sufficiently close proximity to each other to be able to necessarily contract the disease from each other. And so I'm going to skip on past that just in the interests of keeping to time. So as I said, the two questions really are, well, did COVID-19 in local areas around football clubs impact competitive outcomes in contests? And have COVID-19 infections had direct and potentially lasting impacts on productivity in a specific case of footballers? So thinking about local COVID prevalence on outcomes, it's a very simple empirical approach, just simply to look at each game that took place. So we've got the outcome of some measured outcome of a game. Could be goals, could be wins. We just look at goals and wins so far, but there's no reason why we wouldn't expand that in a game between Team I and Team J at time T. We're going to try and get a reasonably good prediction of that via an ELO rating that we construct. So therefore, we get a good sense of what the outcome should have been. And then on top of that, we ask, well, did local cases make a difference? We include fixed effects or dummy variables for each of the home and the away teams. Excuse me. We also cluster on standard errors on that dimension as well. And we ask the question: well, did cases in the home team's local area in the 3 days or 7 days or 2 weeks beforehand have any impact? And did cases in the local area of the away team have any impact in those few days in and around a match? Excuse me. In terms of the data, the numbers aren't quite as pleasing as this anymore. There's slightly more than exactly 3,000 matches as there were when I constructed this. But there's just over 3,000 matches that we're looking at in the 2020-2021 season, which is almost complete in England. There's a range of leagues. So obviously, there's a significant hierarchy of divisions in England. So we've now got the entire Premier League season as well as the entire Championship, League One and League Two seasons, and then further down National League. And then these are two non-league divisions beneath the National League. This is the FA Cup, the League Cup, the Football League Trophy, and the FA Trophy, lower league competitions and some other non-league matches. The thing about all these matches is that we can use them because we know where each of the teams involved lies within a local area, and we've got the local area data on COVID-19 cases. And so here's a plot to give you some idea of the variation there. This is the raw numbers of cases, and so this is in the 7 days before a match, absolute scale on the left-hand side here. So you can see there are situations where the home team had in the thousands of cases in the 7 previous days, whereas the other team didn't necessarily have anything like as much. And so you can see some significant variation across teams. I've taken logs here just to expand that out and get a sense of what's happening in that black mass of dots down there. There's plenty of variation. It isn't that all teams had the same amount of COVID-19 cases. As you can probably imagine, the spread of the second wave in particular moved around and hit different parts of the country at different times. One of the tables I would like to have added in my update was to actually look at the difference between the home team, well, the difference between a team and their opposition throughout the season, to get a sense of whether certain teams were more badly affected than others. The teams that were more badly affected than others were actually more the teams in the Midlands. So Aston Villa, Coventry City and Birmingham City are the 3 teams worst affected by COVID over the last season, to the extent that they probably would have, without COVID having been in existence, they probably would have all 3 of those teams would have finished 2 or 3 positions higher than they did. So it had a significant impact on points outcomes. Jumping ahead, I should actually present the results before saying that. This is a table of those regressions where we're looking at the first 3 columns here are the outcome for the home team. So it's just simply a 0-1 variable, 0 if the home team doesn't win, 1 if the home team wins. These 3 columns are an outcome for the draw. So 0 if the game is not a draw, 1 if the game is a draw. And then here outcomes for the away team. And again, that's 0 if the away team doesn't win, 1 if the away team does win. I'm aware I could have used an ordered probe, ordered logic, or multinomial, but in the interests of controlling for team strengths, clustering the standard errors and so on, I wasn't aware, it wasn't immediately obvious that I could do it that way, and also these results are fairly intuitive to interpret this way. The first thing to say is that because it's one season, therefore the team fixed effects act as a good measure of distinguishing between teams, such that the ELO prediction coefficient doesn't have what we might expect it to have. It has a negative coefficient. Normally we'd expect, because the ELO prediction is 0 if you expect the away team to win and 1 if you expect the home team to win. So therefore that should be a positive coefficient. When we take out the fixed effects, it is a positive coefficient, but when we add them in, it goes negative. But the interesting parts of the table are, this is cases in the last 3 days around the home team local area, cases in the last 3 days around the away team's local area, and then cases in the last 7 days home team, cases in the last 7 days away team, the last 14 days home and away team. What you can see is that for the home team, the outcome of a home win is more likely the more cases there are around the away team, and this holds throughout if we have 3 days, 7 days or 14 days ahead. So there appears to be an impact on the home team. All the effects are in the direction you'd anticipate. That is, more cases in the home team's local area, the home team is less likely to win. More cases in the away team's local area, the home team is more likely to win. And here's the draw. Well, more cases in the home team's area, you'd expect a draw is more likely. More cases in the away team's area, a draw is less likely. And for the away team, the same. Again, these coefficients look very small, but as you'll recall, some of these coefficients are the numbers of cases is in the thousands. The biggest difference between 2 teams in cases in the last 3 days is 3,000 in our data set. So you can see that this starts to become a meaningful number in terms of sporting outcomes. In terms of goals, the effect on goals again is plausible. So again, this is the first column is goals for the home team, second column is goals for the away team, and the same format here in terms of cases in the last 3 days, home and away team, cases in the last 7 days, home and away team, cases in the last 14 days, home and away team. And again, what we see is that if there are more cases in the home team's local area, they score fewer goals. More cases in the away team's local area, the home team scores more goals, and vice versa. But what you can see is that here the effect is significant, whereas again I should have said stars dictate significance. So I've got it at the bottom here that 1 star is 10%, 2 stars is 5%, 3 stars is 1%. So significant at the 5% level is that if there are more cases in the home team's area, there are more away goals. More cases in the away team's local area, fewer goals by the away team, and this is a fairly significant effect. And again, we're multiplying this by thousands sometimes, especially in the cases of these teams in the Midlands. And so you see these are intuitive effects, and they're bordering on the significant. Some of them are significant, and we've done a lot of controlling here for the variation between teams and in terms of the quality of teams as well. My update that I would have done with those extra 15 minutes, I was going to try and show you the impact that this would have had on the final league tables if we essentially take these coefficients and then multiply them by the number of cases in each game for a team's season. We then add up the cumulative effect of COVID-19 on a team's season. As I said, it had a significant effect on the Midlands team. So Aston Villa would have finished above Leeds, according to these calculations, and Birmingham and Coventry would have both finished a few positions higher. The only substantive outcome that I can see that would have been different would have been that Oxford United in League One would have been pipped by Charlton Athletic into the playoff positions in League One. So it doesn't actually appear that there was actually any, in terms of promotion relegation, any substantive differences. Certainly not in the Premier League, where it was very clear cut that the bottom three were far adrift. Also at the top, Manchester City were significantly further ahead of Manchester United. So there's no substantive differences apart from who made the League One playoffs in terms of the impact of COVID-19. But given that some of these impacts were in the magnitude of a point or two, it could have had a difference potentially, arguably, if the disparities weren't quite as large as they were, say, in the Premier League. So that's wrapping up the first part of the talk. I'm quite keen to go on to the second part. So I think this is very interesting, and I think it possibly relates to a talk earlier on in terms of detailed match level data. The second part of the talk is thinking about the specific effect on players. We might think about that first part, local area COVID-19 prevalence being, well, it affects how a team can operate, how a football club as a firm can operate. Well, another effect of it might well be that, well, the players themselves for the teams contracted COVID-19, and what was the impact on those players? Certainly in England, the data is quite hard to come by. You have to be very clever, and you have to be following Twitter feeds and infer that someone got COVID-19 and so on. Whereas in Germany and Italy, the data is much more readily available on which players have actually contracted COVID-19. And of course, once we know that, then we can start to look at the impact on their performance. Do players who contract COVID-19 return straight away to pre-COVID-19 levels of productivity, or do they have a slow recovery time? Is there any evidence of what we now know as long COVID? And of course, this is a very specific group of workers in the economy, if you like. But nonetheless, it does give some insight into the impact of COVID-19 on productivity levels. I'm sure we've got many friends and colleagues who have contracted the virus, and some of them have ended up with long COVID as well. And it may well be the case that many of them aren't quite as productive as they might have previously been. With sport, we've got a great opportunity to measure this and to have a look at it. And so what we've got is we're looking at a similar type approach to the last time, which is simply look at measures of performance, measures of productivity, you might argue, and try and control for various differences between players, between teams, times of the year, all these kinds of things, reasons why we might expect differences. But then ask the question, were they different after a player contracted COVID-19? At the moment, we've got a few measures, and we're looking at essentially how much players are playing for in the weeks after they return, but also, as much as we can, measures of how well they were doing. So we can look at things like potentially pass accuracy and how involved in a match they actually were. And so this is the data. It's data collected from whoscored.com. And if you go on whoscored.com, if you're familiar with the website, you'll know that there's a nice match center where you can look at all of the different actions that are taking place on different parts of the field, different points in time. It's incredibly detailed, and this is just giving you a little bit of a feel for that. This is the entire Bundesliga season, apart from the final round of matches. The black dots, which are tiny, are all the actions recorded with particular XY coordinates. And so, intriguingly enough, you can see the pitch lines marked out. I'm not totally sure why that's the case, unless they're there, unless it's an optical illusion. And then what have we got else? We've got the red dots are aerial challenges of some form or another, so a high ball and a header. And then the red, so the green dots are shots on goal. And the blue dots, which you can barely see, are goals. So most of the goals are over here because teams are shooting from left to right. But there's a few blue dots here. These are own goals, goals that teams scored in their own goals. And so this is the data on the actual matches themselves. Via Kai and Benedict, we have data on German and Italian players in the Bundesliga and Serie A who tested positive for COVID-19 over the last 15 months or so. And so we've got 77 identified cases, so 77 players that we can identify who had COVID-19 and then look at the impact on their performance afterwards. And in Italy, we've got a few more. We've got 146 players identified out of the 151 cases. What have we got so far? Well, we're looking at the probability of starting games. So you can see the probability of starting a game falls by about 9 percentage points, or 9 log points. Number of minutes played falls somewhat. And then moving over to the right here, we've got some of the measures on passes, so how successful passes were, how many passes were made. And what you see is there's nothing much going on there in terms of passes. That doesn't necessarily mean that's the sharpest possible measure we could have used, though. And what we find in Germany is that it was more likely that a player on their return from COVID-19 was subbed off than subbed on. But they don't make the full-time match, the full 90 minutes as often post-COVID. In Italy, it's somewhat different in the sense that there it appears that COVID-19 players were more likely to be subbed in than subbed off, but still make less than the normal amount of time, although it's not a significant difference. The one final thing I will just present are some time plots of this. So the amount of minutes that a player plays, and when you see the effect on minutes played of having COVID, you can see there's a quite significant drop down after the COVID infection, which is the red line, and a slow recovery time. And the points are all below the mean level before the infection, although not significantly below after a few game weeks. But as mentioned, some of the other effects aren't quite so clear. For example, in terms of passes, there's no immediately obvious effect there. I mentioned that for the German players, it was more likely that they were subbed off, and so there we see that there's these first few weeks after the COVID infection when these players were more likely to have been subbed off, and that would be why they would play a reduced amount of time. And so that's our second look at the impact of COVID-19, trying to understand the impact of COVID-19 on sport. Quite keen to get comments on this second part, because it's very much a work in progress and work we started on. We're keen that it's not an exercise in trying desperately to look for any kinds of measures that we can find, but we're quite interested in suggestions that that participants might have on different measures that we might look at. I mean, I think we might want to look at fouls, for example, because fouls are quite a good indicator of players that aren't quite on the up to speed with the game. And so you can imagine if a player returns from COVID, they might not be quite so easily getting back to the full levels of fitness, so they'll be off the pace, and maybe they'll commit more fouls than they might have done pre-COVID-19 infection. But that's all speculation at this point. And so I've got a blank slide of conclusions. I gave this talk on Friday as well, and I meant to update my slide for the conclusions, so I actually have some conclusions to give. This is an attempt to try and understand a little bit more about the ways in which COVID-19 has affected the outcomes that we've observed over the last 15 months. Not just the obvious, home teams seem to win less often than they used to win when fans were in the stadium. But more deeper than that, we can well imagine that organisationally, COVID-19 must have had an impact on clubs, especially in areas where there were particular spikes in the virus, especially during the second wave. There's some evidence for that. Evidence that it might have made substantial differences in terms of numbers of points gained over the course of an entire season, over 38 or 46 games. But at least from an indicative suggestion, only one substantive difference might have actually occurred, which is the qualification for a playoff tournament. Well, it's also been an attempt to look at the direct effect of COVID-19 infections on actual playing outcomes via players that have contracted COVID. This kind of analysis is obviously of interest from the perspective of looking back, but potentially also the perspective of looking forward as well. Obviously, these decisions were made to carry on with football seasons throughout the midst of the second wave here in the UK, and it could have well have been that detrimentally harmed some teams, whereas it benefited other teams. And again, we might well be quite well placed to think about the lessons that we might learn from this for future pandemics of a different kind, or indeed subsequent waves and variants of coronavirus itself. At that point, I will stop, and I'm happy to take any questions and suggestions that folk may have.
Okay, thank you, James, for your very nice talk. So are there any questions for James? Please raise your hands, or you can also switch on your microphone. Actually, I guess I cannot see the chat. I don't know why. So Yanis, if you see any kind of message from the chat, you can give the floor for any question, or otherwise you can switch on the microphone for whoever wants to have some questions. Okay.
I have one question for James. James, I didn't catch for the players, what was the performance indicator you used? I think you used multiple indicators.
Yeah. So at the moment, we've just looked at whether the players were playing, whether they were subbed off, subbed on.
All these variables.
And then we've begun to look at their passing performance. There doesn't seem to be much of an effect on that, but I'm not convinced that's the sharpest of measures. I think what we want to think about is how well linked in a player is on their return. So how do they function as part of the network on the field, for example? And I wanted to look at fouls as well, because I think that's something that will really show the impact of a player not being on the pace. But at the moment, it's mainly just the really simple metrics of passes complete, number of passes per minute, things like that.
Okay, thanks.
There is a question, I guess, from Mikhail Sagris. If you can switch on your microphone.
Yes. Good evening.
Hi.
I would like to ask James, what are his comments about the low values of the R-squared?
Low values of the R-squared in the
models.
So yeah, I mean, I would say that some of that is to do with, I guess you're referring to the linear probability models looking at outcomes. So that's a 0-1 variable. And of course, whenever you fit something to a 0-1 variable, you don't tend to span that 0-1 interval so much. So it's quite common that you get low R-squareds when you've got a binary variable like that. I mean, we're including the kinds of variables that you'd expect to do well in terms of forecasting football match outcomes, particularly the ELO predictions. There's evidence out there that these are particularly effective at predicting outcomes. They're not perfect, but I think, while I wouldn't say I'm not concerned about it, I'd like it to be higher. Equally, I know that it's never going to be really high, just because when you're running a linear probability model, you don't tend to get R-squares that high because you're in that 0-1 interval.
Okay, but what about the other models? They're a bit higher, but they are still low.
So with goals scored, yeah,
yes,
they're not as high as I'd like. I'm not going to deny that. I'd like to get them higher, but again, there's not. It's a variable. It's got a lot of, if you have if you run Poisson regressions, that kind of thing, you don't really get to the kinds of range of goals that are scored in terms of actual outcomes when you've got your expected number of goals coming along. So I don't wish to excuse myself for not having the highest R squared. It's still with fixed effects for the home team, for the away team, controlling for different team strengths. I think it's still a reasonable model upon which we can see that there does appear to be, when you've got these variations, local variation in COVID cases for the home team and the away team, there does appear to be a systematic effect over quite a few games over the last football season.
Okay, thank you. Thank you, James. So other two quick questions, I guess. So Tony Fortes, if you want to switch on your microphone.
Hello, James. Hello, everyone. I want to make you a question because what you did was study like the English tournament. My question is, like, the KPIs that you use was based only on this tournament. Making the question in a different way. It's like, for example, here in Spain, I want to do the same thing. I might use a different type of key performance to make this study, isn't it? Because like the way of playing is going to be different. What do you think, or not?
That's a good question. I mean, I think obviously for the very crude outcomes of wins and draws and losses and goals scored, I think that would be the same. But I think you're right in terms of those very refined within the match level actions, because I imagine the aerial contests, there will be a different level of aerial contests in England versus in Spain would be my guess. I think the English game tends to be that bit more aerial still, whereas the Spanish game is much more on the ground. So I think very good points. I mean, as I said, as I think I showed you, we've only got so far the Bundesliga and Serie A. We'd like to think about England and Spain as well. I think when we did that, we'd want to be certainly being aware and taking measures to make sure that we're not falling foul of ignoring regional variations like that.
Okay, well, it's only that question. Thank you so for the answer.
Okay, thank you. There is one more question directly from the chat. I'm going to read from Giannos. There are a few kinds of research showing modified standings and team plays depending on injuries. Is there anything like that depending on COVID?
I don't know of it yet. As I said, I was going to include it with that extra 15 minutes that I didn't have to prepare my talk in. So I hope to provide a modified standing for the effect of COVID. And if there's, I mean, I don't claim to be the only one that's ever thought about this. And so if there are other ones, I'd be delighted to learn about them, certainly. And the injury aversions as well, I think will be quite interesting to look at.
Okay. Okay. Thank you, James, a lot.
Thank you.
For your very, very nice talk. I guess maybe we can try to switch it to restore the previous speaker. So Costas Pellegrinis, are you there?
Yes.
Okay, great. Now we can hear from you. So if you want, you can try to share your screen, your slides. The Costas talk is titled Positional Value in Soccer. So we give you the floor.
Okay, great. Thanks for the introductions. Apologies for the technical difficulties, but it seems that we cannot have a conference without that, even remotely. So today what I'm going to present is a work for getting a feel estimating position value in soccer, and mainly a framework that could be adapted possibly in other sports, but also in soccer with better data, as we will see. So the objective of this framework is to basically try to obtain a way to evaluate players by using available open data, public data. So obviously there is player tracking data that teams have been using to quantify things that we couldn't quantify before when we only had information about on-ball events. But today we also have a number of public data that people have used in the past, and we are trying to see how can we use some of this data to get some things like wins above replacement, an open version of that. So obviously it will not be as accurate as if someone had tracking data, but this could be a starting point on thinking what you can do if you have this, let's say, older data. So this is a work actually with Wayne Wheatstone that you can find on JQAS, and also the code, we have the code available if you want to play around with it. So in order to evaluate players, as we were thinking about the problem, it became clear that first we need to also quantify the value that each position provides to a team. So if we have, let's say, two players of the same quality based on some player rating, but they are in different positions, the question that this positional value is trying to answer is who has the biggest impact on the team winning. And now, of course, since in football you have also draws, instead of talking about win probability, we are going to translate that to league points. So the question then becomes, okay, we said here that we have two players of the same quality, but how do we quantify this quality? And of course, we said that we don't have access to tracking data. So where we decide is using FIFA ratings for players. So when I'm saying FIFA, I mean the video game. There is research that have shown that they are fairly accurate in terms of quantifying the overall quality of players. So for example, FIFA ratings will look like that, where you have an overall rating for the player out of 100, but also you get a history version. Now, these ratings do not update frequently, do not update every game. They update about twice or three times a year. So you can get access on that from the SAW website. So the question now, the question we are trying to answer now in order to get the positional value is, if we have a player in a specific position and we sub this player with another player that has 1 point rating higher. So if we take, a striker from rating 90 and we substitute him with a striker with rating 91, how does this impact the expected league points for the team? So in order to answer this question, we will need obviously game data. So we will need to know the teams that played, the players that played, the position of the players, the FIFA ratings of the players. Ideally, we would like to have substitutions, and of course the final score. Actually, there is a data set like that on Kaggle that it has about that has 8 seasons of data from 11 European leagues, and we use this data. So the first thing that we did is that using these models, we built a win probability model where the dependent variable obviously was the final result of the game. And as independent variables, we use the difference of the ratings of the positions that the two teams had. So for example, we took the striker of one team, the rating, and subtracted the rating of the opponent striker. And we will talk about a few other specifications at the end, but that's the model that I'm going to be presenting. Now, of course, there is some data sparsity because for example, some teams play with 3 center backs, some other teams with 2. There were even a couple of games with a sweeper, which it's not very common today. So in order to avoid having this data sparsity as a first thing, we grouped the positions to the different lines. So we had the goalies, defenders, middle field, and attack. So the independent variables essentially were the differences in the average ratings for each one of the lines. So there are various ways to approach the modeling part, right? So we could have, you know, a general classification, multi-class classification problem where we have 3 classes: win, loss, and tie for the home team. We can have 2 independent Poisson regressions for the goals scored by the home and the away team. We can have bivariate Poisson regression in order to also consider the correlation between the goals of the home and the away team scores. And then the one we are using in this work is we are using a scalar regression, where essentially what we are modeling is directly the goal differential between the home and the away team. I won't get into the details of the scalar regression model itself. Carlis and Jufras have several papers on that are very good references for this model. But as a very high level description of what the scalar regression does is that it makes use of the scalar distribution, which is the difference between 2 Poisson distributions. And the benefit of this is that these distributions can be independent or correlated. So it doesn't. It is the same form. Doesn't matter if you know, the goals scored for the home and the visiting team are correlated or not. So we model directly the score differential. So if you have, for example, these 2 Poisson distributions that represent the home goals to be scored and the away goals to be scored, then the scalar is simply their difference. So the probability of a win is simply the probability that this difference is positive. The loss probability for the home team is the probability that this variable is negative, and the tie is the probability that this variable is equal to 0. So as I said, the scalar regression model, essentially what it does is that it uses as our dependent variable the goal differential, the final goal differential, and our independent variables is for every line we take the average rating of the players that played in the game, and we subtract the home from the away team. So these are the coefficients we got for the regression coefficients we had for this model, which we fit using maximum likelihood estimation. And before using this model, we wanted obviously to evaluate how good this model predicts outcome. So we were interested obviously in the win probability, how well calibrated it was. And for that, we performed some out of sample evaluation in terms of calibration curve. And here we see that basically for all win, draws, and losses, the calibration curve was fairly was pretty well calibrated along the y equals x axis. So the calibration curves essentially represent what is the predicted probability and what is the observed probability. So for example, if we bin all the instances where we predicted a home team win between 45% and 50%, how many of these cases ended up with a home team win? And here, since it is along the y equals x axis, it's what you expected between 45 and 50%. Now, the interesting thing, of course, is to see that for draws, which is the red curve, the draw probability doesn't go more than 30% the majority of the cases. Now, we also wanted to see the prediction error in terms of the actual goal differential. So we took the real goal differential, the predicted goal differential, and we saw the distribution. So it was centered around 0 with a standard deviation of 1.8 goals or close to 2. So the model is well calibrated. The probabilities are fairly accurate. So we can now use it to see how we can evaluate the positional value. So if we want, the first step is to see obviously how we estimate this expected league points, which is very simple. Just take the probability of win multiplied by 3, plus the probability of a tie, since you get 1 point. So this is how you can estimate the expected league points from a specific game. And now let's see how we can use this to start evaluating players. So the evaluation typically, and that dates back to the baseball days, where basically what teams wanted to do is to see how does a player compare to what they call the replacement player. And this replacement player, essentially what is a player that can basically acquire at zero cost. Obviously, there is no zero cost anywhere, but what this essentially means is at a very low contract, let's say at the league minimum. I mean, in soccer, in football, there's no minimum, but for example, in other leagues, there is a league minimum. But essentially, replacement player is someone that you can acquire very, very cheaply compared to other players. So the first question is, okay, that's the definition of replacement player, but it's pretty high level, right? So we want to see how this replacement player, this definition, maps to what we know about players, which is, let's say, the FIFA ratings. Now, different positions have different replacement players, and that's true for all sports and football as well. So the way we went about estimating the replacement player levels was excuse me, by basically getting salary data. So we got salary data from the English Premier League, and we found for every position the average rating for the players that were in the bottom 10th percentile in terms of salary. So we took all the goalkeepers, we sorted them on a descending salary, we took the bottom 10th percentile, we averaged their ratings, and we found that it was 68.3. And we did the same for defenders, midfielders, and attackers. So we literally took the high-level definition of replacement player and basically the zero cost, we substituted with the bottom 10th percentile of the salaries for every position. So now what you can do is that if you assume that you have a team with all players being replacement players, so essentially all of the players having these ratings that we see here, and you take one player, let's say a midfielder, and you substitute with another player that has a specific rating, FIFA rating, higher or even lower. How does this substitution change the expected league points from the game, right? So this will give you an idea on how this player will impact the win probability, the expected points to win from the game over a replacement player. Now, it should be evident that formations need to be clear and need to be considered. So if we have a formation, an attacker on a 5-4-1 formation, obviously the attacker is very important because it's the only one, so compared to 3-4-3 formation. So even though we don't have this information in our data, we kind of considered it considered an average case when we did our evaluations. So, for example, the expected league points above replacement for a specific player is basically three points, and the change at the win probability that you have plus 1 point, and the change in the tie in the draw probability that you have when you move from all replacement players to all replacement players except the one that you substitute. So that's the change in the win draw probabilities. So for different formation, we did this exercise, and basically we use the four most common formations. So we see in a 4-4-2 formation, well, this figure might not be very visible from in a small screen, but what you can see is that basically obviously as you increase the FIFA rating of a player for all positions, the expected league points above replacement are increased. But we see that there is a quicker increase, let's say, for midfielders as compared, let's say, to goalkeepers, which you don't gain much. Now, in a 4-5-1 formation, we see that the biggest benefit comes from the attacker. So an attacker of rating 90 will give you about 0.4 expected league points above replacement for a game, as compared, let's say, to a defender that will give you, about 0.28, 25. Now, overall, if we take the average of all this formation, just for the sake of presenting, just single figure as a takeaway, we can see that basically the defenders are the ones that give you. So if you have a player with the same rating but with a different position, let's say at the 90 range, the defenders are going to give you more expected league points above replacement player. Obviously, the midfielders and the attackers pretty much the same, and the goalkeepers will be the one that provides the least value in terms of expected league points above replacement player. So then we want to see how we can use this to do some things to see how this correlates with market value and how much these players are getting paid. So by using the same contract data that we had before, we saw that goalkeepers are the ones that are paid the least, and defenders are also the second lowest in terms of pay, and close to goalkeepers. But the main difference is that if we plot here the expected league points above replacement and the annual salary that the players get, we see that basically the goalkeepers, even though they provide fairly low league value, they are getting paid more than the corresponding players in other positions that provide the same value in terms of league points above replacement. Similarly, attackers, especially at the very high end of expected league points above replacement, they are getting paid more compared to defenders and midfielders that provide the same value. So what this essentially tells us is that teams are going to pay a premium to get the same amount of points from a goalie compared, let's say, to a defender. And also when it comes to very good strikers that give you the same expected league points above replacement for a midfield or a defender, they are also going to pay a premium for that. Now, of course, we will see later that there are reasons for that, but we are going to basically talk about it in a later slide. So what we basically did is we took this contract data 2015-16, and for every team in the APL, we estimated what fraction of salary they assign to each of the lines, the defending line, attackers, goalkeepers, and midfielders, and what should have been the salary based on the expected league points that each one of these positions provided, based on the ratings of the players and the model we built. One interesting thing to see is that pretty much all the teams allocate less money on the defense as what their contribution is. And the opposite is for attackers and goalkeepers, whereas for midfielders, it's a hit or miss. Now, the way to interpret this number is that, for example, Arsenal in 2015-16, according to our model, allocated 15% of the 15% less of their budget than what they should have done for the defense based on the ratings of the players. Now, this last column is the mean absolute deviation of, let's say, a fair salary for each position. And we see if you calculate the average there is about 9%. So teams misallocate, if you wish, based on this model, about 9% of their budget to the different lines. Now, of course, as I said, this method only values the own field performance of players, or the expected on-field performance of players. But of course, when it comes to salary and salary values, there are many things that are not game related. Football teams are enterprises, businesses, and you want to maximize revenue. So player marketability, sponsors, all these kind of things are very important when it comes to paying players. So, for example, I remember when Ronaldo moved to Juventus, the sales of season tickets and merchandise pretty much gave a return on investment within 2 weeks of the transfer. Now in EPL also, a couple of years back, the top within the top 20 jerseys that were sold, only 2 were not strikers. So it makes sense from a marketability point of view to overpay some of these players because they will bring you money in a different capacity. So, however, if you are a team that doesn't have a big budget, maybe you can use this type of models to allocate your budget better. So, for example, if you have, let's say, 6 million and you know that your team needs a center back and a you would allocate 2.7 million to the center back and about 3.3 to a goalie. So it will be a split 45 to 55%. So these salaries, so if we go and see what player, what defender we can get with 2.7 million and what defender we can get with 3.3 million, this will give us a defender that provides 0.16 points above replacement per game and a goalie that provides 0.045 points above replacement per game. Now, if we allocate 1 million for the goalie and 5 million for the center back, the players that we can get is will provide us a total of 0.24 points above replacement per game. So this means that with this way, you essentially are buying 1 expected league points at a 16% discount. Now, of course, this is an oversimplistic way to use the model, but it shows you that you can actually start making better decisions about what positions to allocate your budget. Now, other things that you can do with the model is basically at the end of the season, you could see how many points each player contributed to the team. So, for example, that's from the 2019-20 season for Liverpool. And we see, for example, that let's see, that Van Dijk was the one that provided a total of 9 points above a replacement defender, replacement player, and he was, let's say, the MVP of that year for Liverpool. Now, an interesting thing to note is that if you sum all these total league points, what you will get is you will get a number about 75. Now, Liverpool, if you look at the standings for that season, gained about, I believe, 98 points. So what is the difference, right? The difference is what you expect from a replacement player for a team that consists of replacement players only. So actually, if you put down the numbers, a team with only replacement players is expected to get about 21 league points throughout the season. So the math are pretty close. So if you add these 21 points here, we get about 96, 97 points, which is close to what actually Liverpool gained that season. Now, some limitations of the model. Obviously, we have used data only from national leagues, national competitions. Now, if you go at a higher level competition, things can be different. So, for example, in Champions League, the goalies might be much more important than what we found with this data. Also, we have grouped positions into lines, and more fine-grained positions actually can be evaluated if we know the formation of teams and we know how these formations might change throughout the game. So tracking data obviously can help with that. And another way that tracking data can help is instead of using these fixed ratings for players, which is the FIFA video game ratings, we could actually gain some better insight on how players actually played in the game. So if we use the tracking data to see how they actually performed. So for example, in American football, there are companies that essentially do grading of players. So there is a game and they provide at the end of the game grades on how these players played. So if you were able to have this data, this will be a more accurate representation on how much each player contributed to the game rather than the expected through the FIFA ratings. So that's all. If you have any questions, I'm open.
Okay, thank you, Kostas. So are there any questions? Please raise your hand if you have questions. I guess maybe there is a question for no, there is, sorry, it was for the previous speaker. So okay, I see an raising hand for Konstantinopoulos Yannos. Do you want to switch on your microphone?
Hello, thank you for the presentation, Kostas. Just want to ask you, you based the model on defenders, midfielders, and attackers. So if we made another split of the football pitch and we switch the players from players playing in the flanks and players playing in the central space of the pitch, what do you think would be the differences in the league points and the players' value above replacement?
Yeah, that's a great question. So I cannot talk on what I expect, but I think what you're suggesting is very. It is something that should be done because there are and most probably should be done in conjunction with splitting two lines. So, for example, defenders that play at the edge, right, versus defenders that play at the center. So I think so I cannot speak on how these league points will change based on the positions, but I think it's something that definitely will give a more detailed view of the value of these positions. And one thing I forgot to mention is that we also tried different specifications of the model. So, for example, all were based on the lines, the 4 lines, but instead of taking, let's say, the difference between the attacking lines of the two teams, we took the difference between the attacking line of a team and the defending line of the opponent, and the difference between the two midfield positions. So we tried different specifications, and all of them provided fairly similar results, but all of them were based on the lines. So I'm not sure how things will change when you move to other splitting of the pitch, but I think definitely in order to get an even more accurate view of every position's value, you should do more fine-grained division.
Thank you. Really
Okay,
interesting.
thank you. Thank you very much. I guess Yannis has a question.
Yeah, I think this is similar to the previous question. I was wondering what will be the effect of changing strategy, of changing the lines. Can you adapt the model to do an analysis like that?
Yeah, that's a great question. I believe that in this case, you could potentially build a hierarchical model where you start with the value of every position on different formations and different different formations essentially. Now the problem there might be how to deal with situations where the formation changes, which means that a specific player also changes their role on the pitch. But I think that a hierarchical model would be a nice first approach to trying to tackle this.
Okay. Thank you. There is a question from the chat. I'm going to read quickly. As the team budget is limited and strike expensive, wouldn't it be too hard to find a replacement player of similar quality? Have you considered this form of dependence?
So if I understand correctly, the question is about trying to about the budget allocation, basically, right?
I guess yes.
Yeah. Yeah. So that it's actually an interesting question, and the point that I didn't make is some of the results that we got are due to the levels of replacement player that we have for every position, which are based on salaries and are based on how teams make allocations right now. So to answer, at least the way I understood the question, is that essentially what you want to do is that you want to try and obtain players that will give you essentially one expected league point at a lower value. Now, how you achieve that, I guess it depends on the needs of your team, obviously, and these replacement level ratings that you have and how accurate these are. So there is some dependency there, definitely on the results and the replacement level. So if you define the replacement levels differently, then you will most probably come up with different decisions. And that's, I think, the main takeaway from the work is not that goalkeepers are not important. It's more of the framework that, if you make some more realistic assumptions, which, as I said, so we try to make the best assumptions we could. But if you have better data on making this assumption about replacement players and stuff like that, you will get obviously more accurate results.
Okay, thank you. There is, I guess, one more question from Tony Fortes. Quick question.
Yes, of course, I'm going to be quick. First of all, thank you, Kostas. My question is, for example, for teams that, for example, like we cannot have access to the FIFA rankings because our players, they are not there. How can do you think, or do you have any idea how can we estimate the value of the player?
You mean if their let's say FIFA rankings are not there?
See, for example, like teams where like is a second or third division.
Oh, okay. Yeah, that's a good question. Unfortunately, I don't have an answer about that. The only thing I'm going to say is that, and again, I haven't really examined that in detail, but as long as whatever player ratings you find are consistent, then this framework should provide at least qualitatively the results that you expect. But if you don't have ratings, for teams, and that's a good question, because actually players from second or third division are those that might provide you more value in terms of how much you pay them and what they contribute on the pitch. Sure. If you don't have ratings for these players, it will be hard to apply a method like the one I provided. The thing is, though, that FIFA ratings, actually the way they are being designed, they are, so there are humans, there are scouts that provide these ratings, right? There is a set of scouts that EA Sports has, and they provide an average rating. So of course, if a team has its own scouts that provide ratings for these players, then you could possibly use these ratings as long as they're consistent.
Oh, I can do it by myself.
Yeah.
So, well, thank you so much for your information.
Mm-hmm.
Okay, thank you very much. Thank you, Kostas, for your nice talk. I guess it's time for a break. I don't know, Yanis, how many minutes, since we are a little bit late.
We're
maybe 5, 7.
8:05. So it's 10 minutes break.
Okay. Thank you. See you later.